Hello everyone, this is Professor Capko again. I'm here to show you how to deal with word problems. Algebra students oftentimes fear these, and I'm going to show you how to get rid of the fear, how to set these up. My prior video, the part 1 of this, showed you how to find the length and width. Now we're going to deal with mixing problems. This one is dealing with how many gallons of milk containing 5% of butterfat must be added to 90 gallons of milk containing 1% butterfat to make 2% milk. Alright, so we're looking at how many gallons of milk the 5% milk is being added. So we don't know how much. It's asking how many gallons. So when we've got some question like that, I'm going to make that my x. So we're going to make that the x, and we'll go ahead and show you how I set this up. Alright, I like to do it visually. So I know that I'm starting with a container of milk, and I'm adding it to another container of milk, and we're going to wind up with a combined container of milk. So that's as fancy as my drawing gets. It's some boxes. Alright, so we know that we are adding 5% milk, so I'm going to put 5% here, and we're adding it, so that tells us addition, adding it to 1% milk, and we end result, we want to have 2% milk. So we want to wind up with 2% milk. So we have 5% milk, adding it to 1% milk, and we're going to wind up with 2% milk. Alright, so how much are we adding? We don't know. So I make that my x, my variable. And I like to make whatever we're looking for the variable. That way, once I solve for x, I've got the answer to the problem. I don't have to do anything else. How much of the 1% milk do we have? Well, we got 90 gallons. And then how much are we going to make at the end? Well, we don't really know. So what should I put there to represent it? A lot of students would say, let's put a y there, because we don't know what it is. But then we wind up with two variables, an x and a y, and you can't solve a two-variable problem unless you have two equations. So instead of doing that, let's think of another way to put what this is there, how many gallons we have of it. If you get stuck with a problem like this, just make up numbers and see how it would work. If I said, well, I have 2 gallons of milk, and I add it to 5 gallons of milk, what am I going to wind up with? You're going to wind up with 7 gallons of milk. How do I know that? Well, I'm just adding them together, right? I'm just adding them together, and no milk disappears. No milk is harmed in the process. So I know that I'm adding them, so I'm going to wind up with, I start out with 90 gallons, and I'm adding x to it. So that's how much we wind up with, 90 plus x. 90 plus x. Alright, so the only other thing I'd like to do now is convert these percentages. I'd like to convert them to decimals. It's much easier to work with when you're doing math, and the only way you do that is you divide by 100. So 5% is 0.05, 1% is 0.01, and 2% is 0.02. And it's always good to be in the habit of putting that leading zero there. You're less likely to miss the decimal point there. Alright, so now what we want to do is we want to multiply the amount of milk we have by the percentage of butterfat. So all we have to do then is we've got 0.05, and we're multiplying it by x. We're multiplying this by that. Bring down my addition sign. We're multiplying the 90 times the 1. So I've got 0.01, and I'm going to multiply it by 90. And then I bring down my equal sign. See how we're turning the visual into an equation. And then I've got 0.02, and I'm going to multiply it by 90 plus x. So now it looks more like an algebra problem. Now let's do our multiplication. 0.05 times x, that's pretty simple. I don't even have a calculator for that one, 0.05x. Bring down my addition sign. and I've got 0.01 times 90, that's 0.9. Bring down my equal sign. Now I've got what I have here is 90 plus x. That's called a binomial because there's two terms there. I can't combine the 90 and the x because they're added together. So I got to multiply and I got to distribute. So it's 0.02 times 90. 0.02 times 90 is 1.8, and 0.02 times x is plus 0.02x. I just distributed that. Make sure you're familiar with how to do distribution. I can do a video on distribution as well. Okay, so now I've got an x on each side. So to solve this, we want to get our x's together. We can move this one this way or this one this way. I'm going to move it this way because I prefer to have a positive x. So I'm going to subtract 0.02x from this side. And following the pony rule, subtract it from that side. Draw a line. I've got the x's here. This one, so this becomes 0.03x. And I'm going to add to it, I bring this down, the 0.9, bring down my equal sign, bring down my 1.8, and then 0.02x minus 0.20x is 0. I don't need to write anything there. Alright, I still want to get the x by itself. We're trying to solve for x, so I'm going to get this 0.9 out of here. It's addition, so I do the opposite. I subtract 0.9. If I do it to one side, I'm going to do it to the other. Draw a line. I bring down my 0.03x. This becomes a 0. Bring down my equal sign, and 1.8 minus 0.9 is 0.9. I want to get the x by itself, the relationship between the 0.03 and the x, that's the coefficient in the variable, is multiplication. So I do the opposite. I divide 0.03, and I'm going to divide this side by 0.03. 0.03 divided by 0.03 is a 1, so on this side we have an x, and 0.09 divided by 0.03 is 30. So my x is 30 gallons. 30 gallons. So we're adding 30 gallons to 90 gallons. So if the question also asked how much do you wind up with, well, it's 90 plus x. I got 90 plus x, but instead of the x, I can pull it out and leave an empty box there because I want to find out how much I wind up with. The x is 30 gallons. So 90 plus 30 is 120 gallons. We wind up with 120 gallons of 2% milk. That's how you solve one of those problems, and I can check it by plugging everything back in. I can go 5% times 30, and I add to that 90 times 1%, and that should equal 2% times 90 plus 30, which is 120, 2% of 120. And it will balance out, and it will definitely work. So that's how you do the mixing problems. I hope you found that helpful. Rewatch this as many times as you need to get it straight. It doesn't matter what the mixing is, if it's liquids or solids or whatever, the same strategy is going to apply. Again, this is Professor Capko. If you have other problems that you want me to solve or questions, go ahead and put them right in the comments down below this video. Also, if you liked it, click like. And for further updates and to keep up with this, go ahead and subscribe to my channel, and you'll get the latest, greatest. You'll be notified when a new video comes out. Thank you for your time, and good luck with solving those word problems. This is Professor Capko. See you next time.